taking by Dr. Prabhat Kumar. As I have already told you, it will be based on the sensor as well as IoT system, which is useful for smart farming system. So over to you, Professor. Please proceed with your session.
Am I audible? Screen visible?
Yes, sir.
Yes, sir.
Okay.
Both are proper.
So again, starting from just IoT introduction again, that whatever we spray the sensors in a field, it will be transmitted through the coordinator to an IoT gateway. And once we connect it to cloud and internet, we can control it from anywhere. So this is a typical IoT ecosystem. And as I was telling you, the 3 C's of IoT architecture, it's collect, communicate, and control. So we have seen this also, that just like our human body, those 3 C's are very important. Sensors in that many types of sensors are available. A introduction has been given earlier. I want to show some recent advances in the sensor side. So let us hear a Google interaction sensors, okay, how it's working. So as we can see that now you don't even need to, and even in your field or in real-time deployment, in the future this range will increase, so control these things without even touching. So the sensors itself are also in the development phase. So is battery technology, and so is this communication protocols. So the IT industry as a whole is developing very fast, and in near future we will have better sensors, better protocols, and so the deployment scenario and the life will be further improved. So as you can see, with after collection, what we need to communicate those things. Communication, we have many options depending on the size, the kind of requirement. You can choose anyone, and finally, once you get connected to an IoT gateway, you can use your LAN, WAN, and connect the devices or control the thermostats, the sensors working from anywhere as per your convenience. Again, let us see the future of this. So as you can see, I wanted to show you the future we have in store. As you can see, our car, our automated devices doing work, collecting coupons, moving through it. So it was more towards a smart city. But then, can a smart city work without proper agriculture delivery, without proper and quality products reaching to the people as per the need? So we need those kind of integration automation also. So IoT as individual sensor to IoT in actual deployment working together, as you could see, the future is when the devices will talk to each other without human intervention. You will get work done without human intervention. And so let's now move to the IoT applications in agriculture domain. We all know hydroponics. Being most of you from agriculture, I do not need to mention much, but that's how we are increasing our supply in control environment. But when you control environment, you need sensors at every level. Otherwise, how are you going to control? So whenever the hydroponics come into picture, it is a complete control through sensors data. And if you automate it, IoT is a reality. And it is a reality now. You can see livestock monitoring, especially in developed countries where the population is very, less density of population is less, a farmer living in a remote village. And so then you cannot have people, the kids going with the cattle, and also how to keep track. So you can have those sensors. And additionally, these sensors can be made to uh, judge the health of the cattle itself. So there are sensors which will not only share the their inform you in time for all the medical attentions required. Fish farming, again, there is a dependency on fish for our normal food, but we have to monitor. For the one aspect is improving the yield of the fish per square meter or kilometer of the area or whatever. But then if the fish get contaminated in any way, that will reach to humans. So the additional factors is you have to monitor the quality of the fish, and which is directly dependent on the quality of the water in which it is being fed. So fish farming also need complete control. Otherwise, it will reach, may have, undesirable consequences. Let us see how technology and agriculture and, you will, these are the some of the latest news, 2021 July and all. See the amount of money being invested by government, top companies like Microsoft and all. And finally, our people are getting the benefit. But new app promises to tell Indian farmers when to sow crops. Now, still the information being made available to the farmers are general information. It is not specific to their fields. It's not specific to a particular farmer. It is okay. Now you can start. The rainfall is going to start on this day, going to close on the you. People are available through local language. So the farmer's perspective is being failed. People are realizing why they are not adopting to technology, and that's where the good companies are reaching to the farmers, trying to understand what is their need. But still, even after all these things, IoT based solutions are not being made specific to the requirement of a particular farmer. But something is being done, and lots of money is there in this field. Now, let us see one actual deployment in a field of a sensor and how it actually sends data. So smart agriculture, as you could see, the sensors you need to know at what depth and how it has to be connected, and all these data ultimately can work only if we do proper analytics on it. As Madam was telling in the last session that they had deployed the sensors and they are getting hourly reports on email. But those reports are again data. We are not getting any information from that, and we are not in a position to automate things. So let us see how it actually the layered architecture of a smart agriculture ecosystem. So the bottom part, start with the bottom. So it's the device layer actually where you actually put in sensors or the farming machines. You are getting the information about the weather, the context, and you have actuators if there is something automatic to be done. So that is all the deployment. The actual deployment scenario happens at the device layer. That is where your costing, the farmer is required to do these things. Okay, but once the devices are there, those are communicated using the communication protocols, and these communication layer protocols makes the data to reach to the data layer. Now, from here things are missing. If the data are not properly wrapped, not properly handled, then those are not that meaningful. So making it meaningful require data analytics layer. And here you need to detect some event, do some real-time reasoning. This is the layer where decision support can come. But there are other things which need to be taken into control. That is the trust, privacy, and security. Because if actual data in your adversary's hand, then what will happen? There are these data can be used even to do mischief with your actual farms. So we need to include those trust, privacy, and security as well as each level. So one data analytics layers start working and you are start getting some information on that. We can always make application programs which work at the application layer, and there you can control it from anywhere. So as you can see, the end user layer, a farmer or a decision maker or a consumer or a policy maker, they all get what is relevant to them. And that is through these application programs which will work on the meaningful information which you analytics layer. So once we deploy actual agriculture ecosystem, we have to take control at each layer level so that our actual system can be made in real-time use. So that is what is our goal, and that's where people are working so that we can get something benefit from all the efforts. So in nutshell, let us see what is the scenario in Indian context today. In the past, we have been using some machines, some GPS tracking. So that is the past. We have been using, the our and move to tractor, and those things were past. What is the present? The present is, as pointed out by some of the people who ask questions also, that the farmer is confused. So previously it was no data. Today the situation is too much data. Everybody is having some data. Your mobiles itself are equipped with so many sensors. So you are getting data. Google will give you so much data about your area, about your. But as a common farmer, he doesn't need. He is not in a position to do all those analytics to combine those data. So the present, the farmer is confused. He know there is a drone. He know he is a mobile. He know there are government agencies. He know data, but he don't want. He wants tell me I have a land, a piece of land having this much size at a location A, and I need money. I have to sustain my family. What should I cultivate? which crop should I decide, and what will be the time frame when I have to do what. Please guide me into that. That is his requirement. Are we fulfilling it? As of now, to some extent, it's an initial beginning. But in the future, this is the future. We have connected weather stations. We have plant sensors in the field. You have UAV monitoring everything. And then the farmer from his home is in a position to monitor, guide, automate things. That is the we are working for, and that is smart agriculture. So the parts involved are collecting data from sources and making it as simple, and specifically storing data in a single location. Single location doesn't mean we are stopping it for having a copy. You can have a copy at multiple locations, but for any meaningful information, you bring your data to a single location so that analytics algorithms can be done. And for that, you need to standardize your data. If you have multiple formats and you're not getting in real time, then it won't serve the entire purpose. You may get some information, but the entire, you need to standardize data. And then whatever you use, there will be some data which are erroneous, maybe due to hardware fault or some specific locational thing. So you have to clean those data, because a few erroneous data has a potential to affect your. So these are data mining steps which we with computer people, we do these steps to clean the data, and then we enrich the data. So we can enrich from other sources also. As I told you, there are so the soil data is one thing, but you can integrate with other data which the government can provide, and you can include the historical data as well, as what happened last year, what happened last year, and all those data can help you in coming to a conclusion, or in help you to decide which crop suitable for your which field and what will be the timeline. Finally, you will end up, once you enrich your data, you can analyze those data, and analyzing data is critical to gaining value from the information you are collecting. Employ tools for analysis should support the results that you want to achieve. So this is the full process which has to be done. Let's see, crop prediction based on soil and environmental characteristics in actual computer science domain. So we have a crop data set which consists of soil condition, environmental factors as discussed. We do the pre-processing. That is, again, if you go, pre-processing means standardizing the data, cleaning the data. So you can do that. And then based on that, you do some feature selection. You use some feature selection techniques to decide which field or which column of data is important to you. Or let's say column C is more important than column D or column A. So you can have weights on that. So, and select those features which are important. If there are some features which are not changing, why to waste time on that? Remove that feature. Include only those features which are in a position to determine or to help you determine which crop is suitable. So those are things come in feature selection. And then these are the classifier, the techniques, the intelligent techniques which can be used and that a suitable crop. So we are discussing here a crop prediction model based on soil and environmental characteristics. If we move further, the data set which is available normally consists of pH, the electrical conductivity. We have written some description, the organic carbon, the nitrogen, phosphorus, potassium, sulfur, zinc. So I'm not going to read this because most of you are from agriculture domain, so you know what are the importance of these factors. The environmental factors include texture, season, rainfall, as well as average temperature. So these factors, if we get, and mostly it is there at the government level, all these data sets are available. Now we need the actual value, the real-time value. That's where the IoT comes into. So basic procedure for crop prediction. Given as input and the set of data imported. Then we do the, as I discussed, the pre-processing. Here, the attributes used in the set of data are transformed into a particular range bringing the set of data into a consistent state, thus avoiding anomalies. Any missing values are removed. Normalization done used to standardize the data. Redundancy is minimized. So that's the goal of pre-processing. In step 3, a feature selection technique is applied on the pre-processed data to select the most important attributes from the data set to create a reduced data set, because the more the data set, the time and the the processor requirement will be more. So if there are some data decision making, let's remove that. Reduced data set is split in order to be used in the training and testing phase. So unless you train your model, it's very difficult to get some results. So whatever data set you get after all the pre-processing and cleaning, you use it for test. So first 70% of the samples are taken as training samples, and then classification algorithm is applied on these training samples. The classification algorithm is trained with the entire training data set to produce a suitable crop. Of the sample, 30% are taken from the reviewed data set as testing. Trained classifier is applied to the testing samples to predict the most suitable crop. So finally, a suitable crop recommended. The result. So one work was recently published by one of my PhD scholars, Amit Bolain, NIT Uttarakhand, this year itself, Feb 22. And what he did was he was trying to find a crop based on the data available to him for a particular place. So he implemented 6 supervised machine learning algorithms to know which is most suitable to give you a better prediction on or selection of a particular crop. So what he took was these are the 6 machine learning models: decision tree, random forest, support vector machine, naive Bayes, XGBoost, and K nearest neighbor. So he data set from Kaggle, and that data set consisted of 4 soil parameters and 3 environmental properties. So the data set included 2,200 land samples and 22 different crops. Each crop contained 100 different land samples. Various crops are maize, rice, banana, mango, grapes, watermelon, apple, etc. And the feature as the 4 soil and 3 environmental properties were nitrogen, phosphorus, potassium, pH level, temperature, humidity, and rainfall. So this is his data set he used for the purpose of recommending a crop. And rainfall and humidity was found to be very important. So we know that the importance of sodium, potassium, and temperature and soil pH. So we have seen he has taken all these things. And these are the relative weights he put in, that the importance of rainfall and humidity on the crop. So this shows the amount of weight he put on which factor. So the temperature and pH was given for his work, it was given less importance. So when we got the results, and these are the results he got from all these 6 machine learning algorithms, where 70% he used for training and 30% was used for testing. So as you can see, based on this result, XGBoost outperformed all other machine learning algorithms on his experiment. There are competitors, but the naive Bayes and RF also were very near to it. But on this data set, XGBoost have an accuracy of 99.31% in crop recommendation. So that's what was his work. Now I want to take you to a more required rather, and we had done some really good work on this, and that is how as a computer people we can help the farmers in real time. And this work has been again published in SCI journal, and it's optimizing the food supply chain. So let us see from a IoT perspective and from a different side, moving from away from these sensors and getting data. Now let us see the supply chain perspective. Can technology, can IoT help there? So food supply chain is a key aspect of agricultural domain, involves a number of entities that act as intermediaries between the farmer and the final consumer. It is responsible for about 75% of the total net margin. Please see it. 75% of the cost is not reaching to the farmer. If you are paying 10 rupees, the farmer gets 2.5 rupees. And after all these 5G, 4G, Geo and all, still, so can we do something here? So we are trying, and hopefully we will do something good. So the farmer receives seeds and fertilizers from the suppliers. Farmer have the choice of selling the food product either directly in the market designated as distribution centers or to a local trader. Local traders act as an aggregators of the fresh food products acquired from different farmers, arrange for all the necessary transportation vehicles, sell the aggregated food products at the distribution centers. So these local people are in between. Retailers procure these food from the distribution centers and sell them to the end consumers. This is the normal food supply chain as of now. Diagrammatically, we can see here a farmer to the local trader, to the distribution center from their traders, and finally we consume it from retailers. Now, if we see from 2 to 5, 75% is the costing. Now this man gets 25%. You pay 100%. It's an alarming situation, and that's why this person is trouble. That's why our farmers are committing suicide. And that's where they need help. And that's where we have to step in. So farmers do not have sufficient resources for storage and transportation, because most of us, we have seen around 89% are small farmers and they cannot afford, not at village level, they have little quarrels, they have little issues, little egos. So they are not a collected lot. That in Indian context, that makes the situation a bit more challenging. So what they tend to sell them to a local trader at a very low margin. Rates at the distribution centers are not standardized. Only few crops get standardized. That also there are so many middlemen and so many bottlenecks. The farmers can be cheated and forced to sell their products at a low cost. Consumer demand for traceability. Now this has increased with health consciousness, with COVID-like situation. Now the consumer want to know more from where it is coming. Is it organic, or are they using this or that? So as a farmer, he is not in a position to tell it directly to the buyer, and that's way it is affecting. He might have used the best of the water, best of organic file, but he is being paid for that because he is not in a position to sell these things to the actual user, tell these things to the actual user. So even his efforts are being taken away by the middleman. So the possible solutions, again, as I was telling, we have this paper in architecturing user-centric IoT for smart agriculture, 2019, I think, yeah. So user-generated data can be a key player in transforming the traditional food supply chain to be more farmer-friendly. Now we are talking in a reverse way. Here we are not talking about sensors. Now we are talking about a user-generated data from the market. It's a reverse way. That can be very much a to a farmer who is having a hard time. So market rates along with demand made available to the farmers in real time, if we can make it available to real time. And that is possible with IoT, with our technology. The benefit, saving in time and effort of the farmer, which would otherwise be invested in visiting different markets in person. Maximize profit for farmers by recommending the most favorable market for his product. Let us say the farmer is selling his product on Sunday, he is getting all his cultivated food at his house. Now where to sell it? How will he know what is the, let's say he has two cities, A and B. One is 30 kilometers from the village and another is 50 kilometers from the village. Should he go to that city A or should he sell to city B? So those kind of problems. And if he has a small quantity, should he be take or hire a vehicle for that? Will his profit margin sustain that, or should he sell to the local trader? So that is the issue. So the customer request directly communicate to the farmers. So the benefit is if a customer can directly communicate to the farmer, he will get much better profit, and the user will get fresh food at a reduced rate. So the beneficiary should be either the user or the farmer. The middleman may charge what is actual, but here the things are not that. So the problem scenario we have discussed is that the different rates for challenges. Manually visiting the distribution center is not feasible for farmers because of distance, fear of being cheated, because you have different distribution centers around you. A particular village may be surrounded by 3-4 big cities, but where to go, when to go, and then distance. If we can improve Google Maps and all, even the traffic time is an important issue, because most of the crops are perishable. So you might get a good rate in Mumbai, but is it possible that you take a perishable crop from Patna to Mumbai? No. So we have those many challenges, factors to consider before recommending something to a farmer. And multi-objective optimization. It's not a single objective. And that's a computer science problem. And we have tried to handle it. The solution: online availability of such information, intelligent algorithms that consider factors such as demand, cost, distance, etc., for suggesting the most suitable market to the farmers. So that's how a framework has been proposed, that every user will have a user profile manager, and in our contact list we will have a new contact management as well as a existing contact management, and there will be a contact group manager, and this all will work on top of your phone book in the mobile. Little bit of additional software is required which can make you handle your phone book in an organized way. Like you can add farmers, you can add people, and the farmers may contact you. So the user location requirement, you can put it here, and based on that, based on the farmers data, the farmers can put their availability and the user will put their request. Both can be matched, and the system in real time can provide the user on his mobile a proper, you can say, recommendation that you can buy crop A from farmer B. And this all can help reduce the job of middleman. Now also middleman needs to be used only for the transportation part. So my buyer is paying 10 rupees and the transportation cost is 2 rupees, then he will get 8 rupees. Earlier, the cheater or the middleman can tell the farmer that he is selling in 5 rupees only and his costing is 2 rupees. So you get only 3 rupees. So our work was to bring the user direct in touch with the farmer in his language. If I know English language, I will type in English. If the farmer know Hindi, he can do it in Hindi. Let this system, the framework, take care of all these things so that there is a communication between them and there is an agreement between them. And even if we keep this context and these historical data, in future, the trust factor will increase. So let's say you are normally you buy 1 kilo of vegetable from market. Okay, now tomorrow you have a wedding at your family and you require 100 kg of the same vegetable. Now you may need to contact the farmer directly, and that will save you and you will get fresh and better product. So that's how we can enable technology to help in real time. The farmer is required to upload the produced information such as crop type, crop quantity, etc. using the user data requirement module. Intelligent recommendation module of the proposed framework will retrieve the location of different distribution centers and their quoted rates. The data is used to recommend the most suitable distribution center to the farmer for selling his goods. Location information adds one more level of intelligence, like distribution center is suggested based on cost and the farmer location, because location has, with rising cost of fuel prices, the distance is also an important factor. Once the farmer finalizes the distribution center, live traffic conditions can be utilized to suggest the shortest route to the distribution centers. So this is possible today and is being done, like helping farmers finding the best market rate. So upload his crop type and crop quantity. So now he can have contact with 3 distribution centers, and you can consider visiting the following center. He's mobile, even if he is not good in mathematics and all, the mobile will do his, or the software will do his every calculation and tell him, you have these options. Now we can have better model. Upon this model also we are working on that. Like for me, I have 100 kg of certain product. I'm selling at first location. Now my neighbor farmer, who is a big farmer, he has 1000 kg of the same product and he is going to center 3. So it will make sense, if there is space in his truck, that I put in my 100 also. That in that case, but for that we need communication among the farmer community, and even that can be handled by our device and we do not need to phone anybody. So if this architecture can be further grown, where we can help farmers collaborate among themselves in a particular region, collaborate with those people who are having similar crops, and even those collaborations are being done, then they can bargain better price, because they can contact maybe Reliance food chain directly, big bazaar and also. So if you go and try to sell to a good reputed chain, a smaller amount, they will not entertain you. But if you can form a group and do some sort of aggregation at the village level, and then you can sell it at a better place. So this all will help farmer gaining in more price and reduce the work of middlemen. Rather, the cheating part can be completely reduced, because now the farmer is informed. Now he knows what is the rate. He knows in his language. He understands, okay, he can bargain. So these things can come in, and the government have an overall view of these and do the suggested. We can come up with helping centers at village level. Already people are there, but now only they are collecting information. Let's give them some more load. Let's give them the responsibility to coordinate, collaborate, even train these farmers using technology. So helping farmers selling their products directly to the customers. As you can see, farmer 1 made a transaction with a customer XYZ. Upon successful transaction, the information of the customer XYZ is added to the contact list maintained in farmer 1's smartphone using the contact list manager module. It will be done automatically. Customer XYZ stored in all corresponding farmers' smartphones device. All the customers whose details are stored in farmer's mobile application is grouped under the customer tag using the contact group manager. Similarly, when a customer saves the information of different farmers in his mobile application, they will be grouped under the farmer tags by the contact group manager. So it is working in one way in the farmer side, and it is working in another way from the buyer side, consumer side. But finally, they all are grouped according to their preference need. In future, if the customer XYZ decides to purchase agricultural goods, he may upload the requirement along with other details in user data that will be immediately be flashed. Such requirement of the customer is used by the intelligent recommendation module for providing the list of potential farmers capable of supplying and the required product. So if I'm staying in a particular city and I'm in regular need of a, let's say I am the manager of a 5-star hotel. So I need a good quantity of crops And it will be so nice if I get it directly from the farmer. The farmer benefits, the customer benefits, not only in the price form or even in the quality term. So in that case, what will happen? All those potential suppliers in few, let's say in a few months of time, what will happen? Our mobile phone itself will be in a position to know which farmer is selling which goods. And when I go to farmer, those recommendation, intelligent recommendation, AI and machine learning will reach to us on our mobile phone without we being involved to a large extent. We as a user only need to say, okay, I need, let's say 100 kg of this crop tomorrow evening, 5 p.m. Now that goes there. Now, whoever farmers are willing to supply will be quoting you some rate. And all these things can be done by the software. And finally, you will get the best tree recommendation. You can see the other also, but you can train the system that all the best tree recommendation. Even that will help you with a rating system. Like once you go and buy from Amazon, you see that the seller is 4-star or 3-star and the premium. So all those things are possible with the help of these kind of frameworks. And the concept of trust there. And this has a potential to completely change the whatever way we do today. The module shall fetch the details of farmers stored under the farmer tag from the contact group manager. The application will then mine the relevant farmers capable of supplying the required goods. Farmers existing in the contact list of the customer shall receive a notification on their mobile application through the notification module, informing them about the requirement of the customer and allowing them to upload their rates. When the farmer quotes their corresponding rates for the required good using the submit requirement notification response module, customer XYZ can view the rates quoted by different farmers on his mobile application. And then customer can manually select to view his details and can contact him directly for confirmation. If the farmer agrees to supply the required products, he needs to confirm the deal on his mobile application portal, after which the customer will receive the success acknowledgement of the transaction. So this is how it will actually work. I discussed farmer one added to farmers group in the friend list. It's the farmer, and you upload the requirement, and then the farmer, as a consumer, you upload the requirement. The farmer will get a notification on his mobile that so and so requires this kg at location at particular time. So everything the farmer now knows that Mr. has 5 kg of item at location, let's say at location L on particular date and at particular time. So he is knowing how much will be the cost for transportation, when he has to transport, and after knowing all these, he can quote a rate. And once he confirms the deal, the customer gets, okay, this now, and in the you can get all the details about both the customer and the farmer. Both are able to see each other detail because it's already in their contact list. They can even see the previous transaction what has happened. So in this way, very slowly a list of farmers will get in touch with each major buyer. Each major buyer. So that's our proposed framework can be very helpful both sides, from the consumer perspective, from the farmer perspective. So let us see again what is happening in one another country which has very less land, and how they are using technology for the benefit of farmers and increasing the crop yield.
So agriculture has been around for what, 12,000 years? But did you know that today there are robots that can pick fruit and sensors that know what a plant wants and when? Here are 7 Israeli technologies that are making farming more efficient and more sustainable. Team is famous for inventing drip irrigation, which drips water directly into plant roots. It significantly reduces water and increases crop yields. Today, they offer sustainable turnkey projects that include high-tech greenhouses and advanced control and monitoring open platform.
This open platform wraps up 50 years of experience put it up in the cloud, use this big data in order to serve every farmer worldwide.
Israel recycles over 86% of its wastewater, by far the highest in the world. The Shotdown treatment plant takes raw sewage, filters it again with microorganisms, and cleans it until it's safe to drink. Taranis is an intelligence platform that uses satellite imagery, aerial footage, big data, and predictive analytics to monitor fields and make the best decisions.
We can image a field in a really high resolution, about 0.1 millimeter per pixel. That means that we can see a tiny insect on a leaf, and then we can train a computer to analyze it and find these insects or weeds or disease, and give the farmer a report, and then he can spray according to this report. Just where in his field we can find the weeds, he can apply spraying just there.
BioBee uses predatory wasps to control insects as a biopesticide, and thereby reduces the need for chemical pesticides by up to 70%. Groundwork BioAg uses tiny microscopic fungi to help plant roots absorb more nutrients. This increases crop yield with less fertilizer.
So the fungus effectively that root in an underground web. The fungus can break down nutrients that are otherwise unavailable to the plant and physically mobilize them into the plant.
FF Robotics makes robots with computer vision that can actually pick fruits straight off the trees. Supplant uses big data and sensors to talk with plants to know exactly what nutrients they need and when they need to be watered. With more people on the planet, we need to grow more food with less water and smarter, cleaner processes. This is the next agriculture revolution right here in Israel.
So it is time for us to, check ourselves how far behind we are. Recycling of water above 80%, detecting the plant level, which plant needs water, which plants need pesticides, how much area to cover. So it's really very, you can say, inspiring that countries, some of the countries are doing so nice and have set up a very high benchmark for we Indians to to see and take it as a challenge to achieve those standards, which will result in a better planet, a happy farmer, a better economy for India as a whole. More than 40% of the are dependent on the income coming from agriculture. So Israel has been a role model there. So, and then if we see what are our challenges where we need to work, in the last slide, as you could see, talking about all those technologies which is theme of this workshop also, that the AI, the IoT, the image processing, robotics, everything has to work in tandem together. Then only we can achieve our goal. So the research challenges which we face today in terms of computer science people seeing to the agriculture in itself is that we need massive scaling. We are talking about farmers using sensors. Just imagine how many sensors we are talking about. 1.3 billion people, and around 40% of them dependent on agriculture, and using the day our farmers will start using sensors for actual deployment. What kind of network is required? What kind of scaling we are talking about? We are talking about trillions of smart sensors taking data, communicating those data, the storing, and all those things will become a huge challenge. So the connectivity, the storage. So that's why you can see this domain, the agriculture as well as computer science, both are doing, and we require more people. It's a job-oriented sector, and need to work together. Now creating knowledge and big data, now raw data, and that data, just imagine the volume of data. And we need real-time data. We need decisions based on real-time data. A data of soil 10 days ago is not of that use as the immediate data, whether water needs to be given to a plant or not, whether insects have come to the field or not. We need that immediate data, not the previous data. So we need inline data, and decision has to be taken in real time. And that raw data has to be converted into knowledge, into information using data analytics. Now it has to be robust, maintain a dynamic and mobile IoT infrastructure. It has to be robust. It works a day and doesn't work on the next day, then the farmers are not going to use it. Those are poor people, maybe adopting technology for the first time. So if you do not get trust on the system, if the system is not robust, they might lose interest, and we lose them adopting technology. The next is openness. Now, openness here means, the sensors are made by one company. The architecture is proposed and bigger companies. And so everything has to, the internet service providers are different. So we need to come up with those kind of architecture where the interfaces are common. The product developed by vendor A can integrate with a product developed by vendor B. So we need all those kind of openness in the architecture at the design level itself. And then these two factors are very important. You can kill by an arm. You can also kill by poison. So security and privacy is always there, and it cannot be handled at one level. So security protocols very easily if you are handling it at only the application level. We also work on security here at NIT Patna, and we have seen that unless you consider security aspects right from the sensor level to the framework level, it's very difficult to implement those kind of security. So this is also one aspect. And privacy, again, as I told you, that customer one will know about farmer one and all those things. So that has to be allowed by, it cannot be made automated. Maybe a farmer may sell to a particular customer, but his experience is not good. So he won't like to sell it again the second time. So those things has to be taken care, who is allowing, and similarly. So these are some of the research challenges which people are working, and this areas is going to stay there in the near future. We require more people working together. And at the end, I would like to just share these are some of the references we have tried to include as latest as possible. And just want to tell that it's time for all of us to, from different backgrounds, from different expertise, to work together for a better human life, a better society, for a better world. Thank you. Thank you, Preeti.
Thank you. Thank you very much, sir. Sir, can we take questions from
yes, sure.
Audience?
Sure.
Sir, how best IoT will be helpful to the natural farming?
Very much. I think we are way behind, but IoT is already helping natural farming. Once you reduce the need of water, the pesticides, when you monitor the quality, then only it is useful now for in the food we are eating today. The water nobody is monitoring. You go to a shop, you buy something, you don't know where it has come from, what kind of water, or you see when people around just see the rivers, just see the watering, from where will they get water? Just have a look at the surroundings and you know what kind of irrigation things. You go abroad and eat the foods.
Yes.
go to smaller countries, you go to Malaysia, forget about Europe and, and you just eat the same fruit and see the quality difference among in the taste, the size, and why we are not able to do it. So because nothing is being monitored, and without devices, how can a human do it? So IoT is a must.
Yes. Next is, things discussed are very good, but looking into the scenario of Indian agriculture, what would be the adoption level and what is the economics of these gadgets?
Very good and very valid question. It's easy to say something. It is easy to develop it in an IIT or in a research environment. Your environment, but making it, taking it to adoption level is a major challenge, and that's why the Center of Excellence even being set up at Patna by STPI and Ministry of Electronics and Communication, MIT, and including people from agriculture institutes and scientific institutes. The whole purpose is that the government should know what has to be done. See, there is money. It's not that money is not there with the government, and there is intention also. Now we need to come up with working models. Piti and his team, they're working for the farmers. We also want to do something for the farmers. The government also want to do something. What we require is a model, and we in this Center of Excellence have kept a lot of money for the startup people, for the young people who are listening to me. Please look at the startup opportunities this smart agri is going to give. And in this Center of Excellence, we have even taken care that for patents, the startup will get money, full funding. Even for marketing, they will get money. Let's say they have developed something. They need sustenance. They need 1 year support at least. They cannot start earning profit. So those things were told by the state government. So at higher level, I got chance to present the things at the ministry level with secretaries and all. People are willing to come together, and that's why we are working. So I agree with the questionnaire that unless it is adopted at the farmers level, the whole benefits will not be there. But the framework which I proposed, the software part, the selling, going to the best location, that can be implemented very easily. So we are trying to start at some level, and hopefully with the support of all Indians, we must be in a position to do it.
Yes. Sir, what kind of, the question is, what kind of programming language will help to develop the framework which connects consumer to farmer and the integration among many users?
See, you can do in whatever language. You have built-in libraries, but these easier ones are Pythons, and the today's languages, they make things easier to handle. Even C, Java, whatever you want, but it depends where you are programming. If you're programming the hardware, like you are programming the sensors, then C, C++, those will be better because you can handle the hardware. But if you are programming on the front end side, like giving an app-based solution, then you need to come with Android, Java. So it depends. But wherever you feel comfortable, see, one person cannot develop an entire ecosystem. Nobody, you need a proper design, and on that multiple. If there's a software team, that team should have multiple people. So for the questionnaire, you see what you know better. You will get all the libraries and things for your language. That's not, but definitely you need 1 or 2 languages, computer languages. You can start with Java, you can start with Python. Very good libraries are there for the analytics or for AI, everything is there.
Yes. Sir, how IoT help in reducing the post-harvest losses, especially in fruits and vegetables?
Yes, it's, let's say I'm producing something. So even a farmer, they do have some planning. They look at the sky and then they cultivate get the finished product on certain day, depending on situation. They may, if they do not have weather information, weather can degrade very, but they also plan that I will do this cutting on that day. So now when they know that they are going to cut their fruit or vegetables on particular day, and if IoT give them the demand from the customer directly, let's say Big Bazaar needs this much, Reliance Smart or any, so now they know that this consumer wants a good quantity on a day, certain day. You cut it on that day. So in that case, your goods are not remaining with you for long. So the perishable part is taken care, because every farmer has not access to cold storage and you would not like to give everything at cold storage level. So it does, we can communicate, make them other. See, just how many 5-star and 4-star hotels are there in India? Just imagine. Just imagine the Indian railway use of vegetables and rice and dal. Just imagine the food served in all Rajdhani Express. They are outsourced from somewhere. If we connect farmers, that's all. They are paying, people are paying, ready to pay. The airports, the food courts, just imagine the kind of food courts we have in software technology parks today. A particular area with 50,000 people, young people, earning very good, ready to pay. Now, from where those vegetables are coming? Let it come directly from the farmers. Let's start with big consumers. Forget about people like you and me. Hotels, railways, those food courts. At least, see, we cannot solve the problem of entire India in one day. But even 10% of the farmers start benefiting, the chain develops and that spreads. So in that way, we need to start somewhere. That's what I think. That's my opinion.
Yes. Dr. Someone has written, Dr. Prabhaji, my question is, still 70% and more villages struggling with last mile connectivity. In such circumstances, how does the IoT based farmer centric agri ICT intervention help?
I'm just from the rest 30%, what has they done the mistake? 30% in India, becomes 30 crore. So we cannot anyway solve the 100%. Technology will reach to the masses. The companies are working, infrastructure. It's not easy when you talk about 130 crores people. No, it's not one state. Our one state is bigger than one country of Europe. So we can understand the time being, taken by. Let's not blame anybody, but 30% are accessible. Let's do something for them. I agree that still there are challenges with internet connectivity, but from the farmer land perspective, you do not need communication. You do not need further. You always don't need to be connected. Whenever you feel okay, you just refresh all the, let's say every 6 p.m. in the evening, I will refresh that any farmer is willing to sell. So for last 10 hours, I may not be on internet, but at that time I will get all the requests. So in that way, we have to find some solution. We cannot just wait for, the entire infrastructure to be ready. Let's start doing, because it will also take time. Reaching to the farmer, training them, utilizing it, getting their trust is also time taking. Even the government people who are at the end connecting with the farmer, they need to be trained. It's not easy. So we need to, and young people are so smart, so intelligent that these startups, they will be the beneficiary both way. They will serve the society also and they will earn also. They will come up with some very good models.
Yes.
So that's where we need to start. We cannot wait. We are already behind.
I think, sir, we have done with almost all questions from participant side. Sir, I wanted to know, is it possible to make such kind of IoT devices fully automated, and what are the challenges we are facing while making these devices as independent of human intervention?
So that's a very debatable issue. How independent can make a machine, because there are complete contradictory views by different people. If you make it too much independent, you see what is happening in Hollywood movies, machine versus human and all those things. But those are extreme cases. As of now, a little bit of automation has already begun. Like even in Dubai and all, I have seen automated watering and all. Even in Indian context, you have seen that automated watering, and also some sort of automation has already. Only that much water will be given as is required, and when it will be given, it also depends on. So that automation to some extent is already there. Now getting in robots or making the tractors intelligent, it will take some time. Related to manufacturing, India is a bit behind in terms of the semiconductor design and manufacturing, but the president has taken a huge initiative. We all know that the manufacturing process in India is, we are dependent on our neighboring countries and Taiwan and Japan for. But I think within 2 to 3 years the scenario will change. With Make in India initiative, things is changing and will certainly change. So that's what it's one of the best time for the young people to be in India. All your scholars and the kind of opportunities you are going to see in coming years is going to be enormous. Either you are in agriculture or in software or in hardware. But please work hard and be, knowledgeable. That's the thing.
Sir, actually, I don't know, this is my side internet connection issue, or maybe everyone else is facing the same, because I'm getting your voice with some interruption. So my next question, I'm struggling to listen to you. Next question is, if in case we want to make device, we are actually running in the industry where we always emphasize the scalability factor. So robotic is the area where it is just it is in the situation of evolving, but we can't make it scalable. And while making a robot or devices such a costly instrument, how can farmer take those devices for their farming system?
See, again, in Indian context, because the farmers are small and still it has not been implemented to full that all your land becomes at one place. But in certain states, they might have been. In Bihar, it has not been done. But unless there is a large farming area under control of a particular corporate or a farmer, you are not in a position to use robotics or robots. That can only be done because it's costly. But once your farm size becomes bigger, then it is beneficial for you because.
But sir, it is not in the case of our Indian scenario that most of the farmers are small and marginal landholder. So
that's why
how it is possible to convince them for using such devices?
You even if you convince them, they won't have money to buy robots.
True. So what would be the possible solution?
Let's not go to the possible. The government has already come up with the geo mapping of your entire land, and it is in the process that every let's say a farmer has 5 land at 5 different places in the same village. They are in the process of clubbing it together. So now each farmer gets a land at one place. He will have a bigger piece of land. And then 3-4 farmers today, as is happening with tractor, now everybody doesn't own a tractor. So in future, it will happen with the robots also. If somebody, a good person buy a robot, then other people will rent it. Already electrical equipments, these mechanical devices are in use. So, but it had not reached to a robotic stage. We need more, research and The cost has to come down. Right now, the
Yes.
import cost, that's why Make in India is going to change the things.
Yes. So, sir, this rental thing, like Ola Uber system in this mechanization, does it work? But because we need maintenance also for such kind of equipments and devices. So, does it work in long-term plan?
It will work. Maintenance will create more jobs. That's what's happening. The jobs are being set, Now you need more of the technical for the maintenance of these kind of network, the robots, all these things. But it will eventually come. Once you have bigger size plots, you need these mechanized robots to help you out. So it is in the process. It will take time. It cannot be done overnight, but it is in the process. Even people want it, the government want it, but there are litigation issues, swapping of land is not easy, If whose land is better, whose land is not better, my 100 square feet is equal to 200 of yours. So those kind of, things will happen. But slowly and slowly, either through corporate or even I think someday these bigger corporates will reach to farmers, and then it is possible they will provide these kind of robotics to help them. So things will. So let us move with time. Initially, at least make the software part available to them so that they can interact directly with the customer.
Sir, I wanted to ask one more thing, which is related to sensor. I have heard somewhere that proximity sensor is used to measure the height of particular weeds. Is it possible?
Measure the height of
weeds, unwanted grass in the crop? We can see.
Proximity sensors can be used if you carry the sensor with you. I mean, if let's say you are moving with your mobile and you mobile to a certain height using a stick or something, then all those weeds which comes in close to it, of certain height, you can detect. But
sir,
there are better ways to do that.
Sir, while the growing period of that unwanted grass, the height is very, I think 1 centimeter approximately.
That's what I said. In that case, to use image.
In that case, what kind of sensor we can use and how it will be how it will sense that data that this is feed and this is different from plant.
See, image processing can help better. You don't need to go with a sensor in entire field. You take a snapshot of your that area, and you can have AI take care of all those things. That is being already
but
done.
How the sensor? What will be the format of data which sensor is taking? Whether it is height of the crop or something like ultrasonic sensor, जो कि sound से predict करता है.
साउंड से प्रेडिक्ट करने के लिए आपको ज्यादा मेहनत करना होगा, क्योंकि द फील्ड में बी ऑफ डिफरेंट साइज, डिफरेंट हाइट, द स्लोप, and it may have intermediate plants also. Again, it's better to use image processing in such cases.
So image is the data. Ultimate data to detect that weed is image.
Image, yes. If you have good quality image, you can expand. As you know, it is possible to detect insect also using image.
Yes, sir. That actually I am coming to you because me and my team is actually trying to make one device, IoT device. Okay. And for that, since IoT device is not concerned for just one zone, like if you are knowing AI, then it will be developed. No, because it needs at least sensor knowledge, IoT devices knowledge, robotics knowledge, that designing part of that robot, that fabrication part of. There is so many things which is involved in this. So in this regard, I actually want to associate with you for my own query, our own query. And we will look forward your help in this case.
Okay, ma'am.
So, sir, we are actually end of this technical session, and there are no more questions from audience side. So thank you very much for explaining our audience these two topics, which is sensor and IoT, from the basic and also from the use cases from research paper as well as some relevant examples, sir. So thank you for coming in both of these sessions, and we look forward for your future association also, sir. So
thank you, Priti.
So, dear participants, we are ending this session here, and we will come up with 3 more sessions tomorrow at 10 a.m. Indian Standard Time, and we will be having some discussion on what are the smart system of weed management and IoT, cloud-based IoT system for smart farming, as well as I think. Yes, IoT-based smart monitoring system also. So stay connected with us and have a good day. Thank
Wish you good times to all the participants ahead.
Thank you.